All right, question 12 from the 2016 practice exam. We're given the acceleration as a particle moves along in a straight line. We're also told a couple of conditions. At time equal to 0, its velocity is 10 and its position is 7. So that's going to help us a little bit later when we actually try and figure out what these equations are. We want to know what the position is at time equal to 2. All right, so if I'm given acceleration, what's important to note is that if I take, I can find the velocity by finding the antiderivative of acceleration. And I can then find the position by taking the antiderivative of whatever that velocity formula is going to be. So I'm going to use my antiderivative rules to find a few of these things, okay? All right, so let's start. We have acceleration, we're told, is 6t. So if I take the antiderivative of 6t dt, I'm going to get 3t squared. Now this is plus c. Right? This is an indefinite integral, but we do have this boundary condition. They told us that the velocity is 10 when time is 0. So if time is 0, this whole thing has to equal 10. That means c is going to be 10. So we get 3t squared plus 10. That is my velocity. So now I'm going to go down to the next one here, and let's find position. So I'm going to take the antiderivative now of 3t squared plus 10 dt. So antiderivative rules, I'm going to add 1 to the exponent, divide by that new exponent. So that just becomes t cubed plus 10t, a little sloppy here, plus c. But again, we were told at time equal to 0, the position is 7. So if time is 0, then the position is 7, so c is going to be 7. So my position equation becomes t cubed plus 10t plus 7. And we want the position at time equal to 2. So we want s at 2. So that becomes t cubed, 2 cubed, plus 10 times 2 plus 7, or 8 plus 20 plus 7, which is 35. And that is D.